This is a screencast reassessment for CO5, and the question says, the first question says, two people push in opposite directions on a crate sitting on a frictionless surface. If the crate is initially at rest at point A, then moves to the left without rotating and ends up at rest at point B, describe how much work is done by each person. So if you draw the picture, part A is on the right, it starts there initially, and then part B is on the left and it ends up there, and person number 1 and 2 are pushing it, but person number 1 ends up moving it to point B, which is a certain amount of meters away. They don't tell us. And then the velocity initial is 0 and it starts at rest, and then I just did my coordinate system as right is positive and left is negative. And then it asks how much work is done by each person. So since the crate, no way, it says crated. So since the crate moved to the left, person number one's force must have been larger. And then to prove it, I just made up numbers. So I said the change in x was 2 meters to the left, and my coordinate system just made that negative. So if I did person number 1 over here, the work would have been the force, which was, I just made up 4 newtons, and I said it had to have been larger, so person number 1's was 4 newtons and person number 2 was 2 newtons, and then the displacement was the same, so they started at 0, and then the final was negative 2 meters, so negative 2 minus 0 is negative 2, and then the cosine of their angles changed their signs, so you ended up with person number 1's work being negative 8, and then person number 2's being 4. So the magnitude of those is the work of person number 1 is obviously larger. But then I wasn't sure about one thing about the forces, because since person number 1 is moving the crate, if person number 1's velocity is constant, then I was thinking the acceleration would be 0, and we don't know if they're pushing constantly or not. So if the velocity was constant, or their force, then the net work would have to be 0, because the net work is related to, or the net forces is directly related to acceleration. So if there's no acceleration and the person's pushing constantly, then the net force has to be 0, which would mean that neither of them, or I guess number 1 at least, does no work because there's no force. So that's if they push constantly, but I don't know which one. I don't know if you can assume that he's pushing constantly or not. So I guess there's 2 possible answers. And then for question number 2, it says, suppose you are climbing a rope that is hanging freely from the ceiling of a gym. The rope does not stretch as you climb it. If you climb the height h, how much work has been done on you by gravity? How much work has been done on you by the rope? So for this one, I drew my picture. So initially it starts at the bottom, and then it ends up at the top, and then the positive y direction is pointing upward. And for the free body diagram, it's just their weight going down, which is mg, and then the force tension between you and the rope, which is pointing upward. So for part A, this is the work done by the gravitational force, so the weight. So work equals force times distance. So work equals, the force is mg, and then times the height, and since you don't know the height, it doesn't really matter. And then work equals negative mg, because I said the negative direction was downward, and then so work equals negative mgh, and you know the value for g, so that's the setup for the work between you and that force. But then for part B was I did the work between you and the force of the rope, which is the force of the tension. So originally I did work equals force times distance, and then work equals the force is force tension for the rope, and then the height, and then up here I think it was, oh no, so before I said that they have to be equal because of Newton's third law. So I just changed force tension into mg and then h. So I said they basically have to be equivalent, except for a positive and negative. But then, because of the hint, it said determine how far your hands move while the rope exerts a force on them. And because of that part, I remembered that the distance between you and the rope while you're climbing is actually 0, because your hands stay where they are and the rope stays where it's at. And then, so when you pull up, your hands aren't doing any work, so the work with between your hands and the rope is 0. And it does no work just because your hands aren't actually moving at that point.